Okay, so let's start. So here they're saying the question 5, they're saying the diagram shows the graph of g of x. All right. So the first thing you have to identify, the type of function that are given at the situation, right? So you can see that firstly they gave us the quadratic function. Since you see the curve shape, so this is the quadratic function. All right.
Yes.
And
I
secondly, they
remember
gave
now.
us the
I'm
straight
starting to
line.
remember.
Yes, and secondly, they gave us the straight line. That is the straight line. And
That's
then,
a linear.
yes,
That's a linear function, isn't it? The straight line is a
yes, linear
linear.
function. Linear function,
Yes,
yes.
yes.
So they label this function as g of x. Okay, so this function right here is g of x, while this function over here is f of x, right? And you can also easily identify this function by looking at the equation, the general equation that are given here. Once you see x squared, right, that should tell you that once you see x squared, which is the maximum exponent in that equation, that means that would be the quadratic function. Okay, and then once you see mx plus c, obviously that is the linear function. Okay, so you can also easily identify this function without looking at the diagram so in details. Okay, now let's now start with the first question. Okay, let me just read this. The diagram shows the graph of f of x, and they gave you that, and the g of x, and then they say r and s are the x-intercepts of g, t is the y-intercept of g, and f of G, and graph F passes through R and T. Now, before you do this, T is the y-intercept of G of X, and also T is the turning point of G of X. Do you notice that?
Yes.
Right? So since this is the case, the first thing that we have to do, okay, before we do that, let's just answer the question accordingly. So the first question, which is 5.1, they say write down the range of g of x. Now, remember, if I said to you, if you write the range and the graph that is given here at that time is a smiling graph. So the range will be y(t), which is the y value at the turning point, less, no, sorry, will be y less or equal to yt, right? If you have a smiling graph like this. But if you have a set graph, you have a function like this. If you have a smiling graph, you have a function like this. If you have a set graph, you have y, which should be greater or equal to yt. Now, the question will be, what is yt? Yt is the y value at the turning point. So you have to go to the turning point. You can see that at the turning point, the y value is 8, okay? Because the coordinate is always written in the form of x is to y. So therefore, the y value is 8. So therefore, by you recognizing this, you can see that you will have for the range, this answer over here will be y less or equal to 8. No, sorry, would be y greater or equal to 8, because this is the set graph. So this is the range. Any question here?
Makes
Because
sense.
because you have to remember, when we are talking about the range, we are talking about the values of y, while if we are talking about the domain, we are talking about the values of x. So that is a very important thing to understand and to note. Okay. Now, okay. Now let's go to 5.2. For 5.2, they are saying write down the x coordinates of R. It's look easy, right? Someone can simply say the coordinate of R maybe is -2, right? And I will argue that that cannot be the true at some cases, even though it will be true at this case. But that won't be the true at some cases. I want to teach you to always be critical with your answers and to make sure that you critical analyze the answers. Okay. So remember, I gave you the formula last time. I said if you want to calculate xt, which is the x value at the turning point, you simply say xt is equal to x1 plus x2 divided by 2. Do you remember this formula? right? So I said to you, x1 and x2 are just the x-intercept of the function, of the given function. So are the x-intercept of the quadratic function. So are these values that are over here, right? Now, if you look at the turning point, we already got xt. Xt is 0, okay? So I can go ahead and plug in xt here as 0 equal to x1. I will assume that this side, this is my x1 over here. I have my x1 over there, and my x2 is over here. All right. So my x1, I don't have it. That's what I want. While my x2 is 2 divided by 2. Now I can calculate for x. Now if I cross multiply here, if I cross multiply 0 times 2 is 0, right? So I will have 0 equal to x1 plus 2. Then I'll take 2 to the side. So my x1 would be equal to minus 2. Okay, so you can see that therefore to write the x coordinate of r, so you have to write this in terms of coordinate, because if you left your answer like this, you still have some, you still didn't answer the question. You always have to leave your answer in coordinate form. So you leave your answer like -2 is to 0. Okay, any question here?
It makes sense. It
Okay,
makes sense.
so your answer here will be -2 is to 0. Okay, now there's an interesting part. So now they say calculate the value of a and q. So you can see that here the value of a is on the quadratic function. So the value of a and q. Now remember, I said to you, if you remember this, right? I hope you'll remember, but I know you'll remember. Now remember this. I said the general equation for the quadratic function is f of x equal to ax squared plus bx plus c, right? And I said to you,
Yes.
if the value of b is equal to 0, okay? Okay, so you have the function of f of x equal to ax squared plus c. Now, in this scenario right here, you have to know that the yt, which is the y value at the turning point, is the y-intercept of the function. All right. So so you have to understand that in this scenario, where you have yt, where b is 0, your y-intercept, when you let x be 0, will be also the y value at the turning point. Okay, let me just put it this way. The y-intercept will also be the turning point of the function, right? So why am I saying that? I'm saying this because I want you to understand this. If I go to this function, you can see that the value of b here is 0. We have g of x equal to ax squared plus q. So in this case, they use q instead of c, which is still the same thing. So you can see that we don't have the value of b that's got the coefficient of x. Okay, so that is 0. So you can see that in this case, that means we have the x-intercept, no, sorry, the y-intercept is also the turning point of the function, which you can see is true, right? You can see that that is true because they also, I said that the y-intercept of g, okay, they say
Okay,
the,
so this is coming. This is coming back to me now. Now I'm
yes,
remembering this whole thing.
yes. So now that therefore the value of q is 8, right? So the value of q is equal to 8. Any question here?
No, that makes sense now. It makes sense now.
Right? So now we can have g of x being equal to ax squared plus 8. Now, to find the value of a, you just need any point on the graph, right? So you can take 2 is to 0, or you can take -2 is to 0 to calculate the value of a. Okay, you will find the same thing. So let's take, I will use both of them to show you that it doesn't matter. You can use both of them to find the value of a. So I can plug in the value of a, the coordinate here. I will use this 2 is to 0 or -2 is to 0. You can use any of those. So when y is 0, equal to ax is positive 2 squared plus 8. Now I have to calculate the value of a, so it's 0 equal to 4a plus 8, and take that to the side. So I have minus 8 equal to 4a, and then divide, what am I doing now? Then divide by 4 on both sides, and then the value of a is negative 2, okay? Now, you can find the value of a like this, or you can use the second one, right? It doesn't matter. You can use the first one, or you can use the second one. So if you use the second one, obviously you will have 0 equal to a into negative 2 squared plus 8. Then this will be positive 4, right? Remember, this will be positive 4 because this is the same as negative 2 times negative 2, which is positive 4, okay? So that will be 0 equal to 4a, okay, plus 8, which would also take you back to this, okay? Also, a here will be negative 2. So if you remember last time, I said if you got the value of a that is negative, you have the set function. You remember that? If the value of
Yes.
a is less than 0, your function would be set like that. But if the value of a is greater than 0, your function would be smiling. And you can confirm that by finding the negative value of a and looking at the graph. You can see that the graph is set, so your calculation is fine. It's correct. Any question
So,
here?
so what? So for the linear one, for that one, it's going up, so it'll be positive. Have a positive number.
100%. We'll have a positive
And then
gradient.
if it's going down, of course, negative number.
Mm.
All right, that makes sense.
Okay.
That always makes sense.
Okay. Now, before we continue, do you have any other question?
So in some cases where they give you the equation and they leave out like a number. So let's say they give you this. They give you a point and a linear equation.
Can you
Let's say they
repeat?
give you a random linear equation, but they leave out all the points except for one. How do you can you work out all of those points to find that?
Yes, yes. Like for
They,
this case, you can
they
see that they
leave
gave you the.
out. Let's say they
Yes, you are saying something. Yes, I'm listening.
no, I wasn't. I wasn't.
Oh, okay. So I was saying yes because you can
I'm
see
listening.
at this case they gave you 1 point on this
So
f of x function, right? But you can see that this x function is cutting the turning point, right? So the coordinate here is 0 is to 8. It's also cutting the x-intercept of g of x, right? So where you have negative 2 is to 0. Okay, and if you remember correctly, in order for you to calculate the linear function, you need you need 2 coordinates on the line. Okay, once you got the 2 coordinates, you can then use those 2 coordinates to calculate the graph to find the linear function. Okay,
all right,
right?
all right. That makes.
At this case, they gave you this one. This one you just found, right? You
But
just calculated this. This one
what?
is
But
negative
what?
2 is to 0. Yes, a question? You have a
So
question?
what if in a test they give you the linear function,
Mm-hmm.
but they don't give you, let's say, yeah. My question is, sometimes I've seen it in some tests. They'll give you the linear function, but they won't give you. They'll give you the answer for the linear function, but they won't give you the working out, and they'll leave out, let's say, f, for example, and then they want you to work that out.
Yes, they simply want you to say show that, right? You talk about the question like that.
Uh,
Like for example, instead of asking you to find the value of a and q here, they can just say show that g of x is equal to negative x squared plus 8. They can just simply say this. So you have to recalculate the value of a and recalculate the value of q, which is the same procedure that we did here. So they can ask this question in 2 ways. The first way, they can say show that or prove that the function of g of x is equal to negative 2x plus 8. And the second one, they can just simply say calculate the value of A
Yes,
and Q like they did
that's
at the school.
exactly
Yes. Any other
what they
question?
want. All right. Um, no, it makes sense. Makes sense. I'm just trying to get it in my head right now. As you can see, my life's pretty messy
No,
at
no,
the
that's fine,
moment,
man.
so I'm trying my best.
Let me just say this because I have to tell you this. You remember when I spoke to you last time? I said to you, don't complain. Do you remember that? What are you doing right now? You're complaining. Do you notice that?
I'm not complaining. I'm just saying if you would take a look at what I'm
No, it doesn't matter. You're doing the work. That's
writing
fine.
over here,
And you know
you
that
wouldn't like.
messy is the product of result. If something is not messy, that means you didn't do anything, right?
Hmm.
So it's the product of result. So
I think I might have. Yeah.
so
Yeah, I'm trying my best the whole day. Can I show you what I've been doing?
yeah, no, no, no.
I'll show you what I've
Yeah,
been
you
doing
can show
now.
me.
I've been doing another. I've been
The
doing this
EGD.
type of mathematics, EGD.
So now let's look at this question. So they are saying now in 5.4, determine the equation of Q of f of x, right? So which is, you can see that since this is the quadratic function and you already did the hard part. Let me start taking this to the side on the cleans page. Okay, now it's doesn't look messy. Okay, so
What computer are you using?
sorry. Okay,
What using Microsoft?
yeah, I'm using Microsoft. All right.
So uh okay.
Yes. So let's just finish off that. Now the next
I
question
think
is saying,
this speech is delayed. I think it's delayed.
come again. They're saying something.
I, I think the speech is delayed between our contacts.
Oh yeah, yeah.
Because
But
when I'm saying something, you're not hearing it immediately. I think it's delayed.
yeah, it's delaying, but it's fine.
You see, I'm talking now, but then in a few seconds later, then it's
Yeah, maybe it's the connection. I don't know. I don't know. Maybe it's the connection thing. So now, for 5.4, they're saying determine the equation of g of x. Now, g of x is the straight line. As you can see here, g of x is the straight line, which is that function. So this function is g of x. And we already got the coordinates of r. So this is -2 is to 0. Now, to find the function of g of x, we only, since you can see that is mx plus c, we only need firstly to calculate the gradient. The gradient is the change of y over the change of in x. All right. So that will be y2 minus y1.
I mean, it's a change of y and a change of x.
Yes, yes. You want to try it?
Uh, I can.
Okay, try it.
Uh,
Try to find to determine the equation of
yeah, I
g.
think I can.
Yeah, and because we have this point, we have that point, and then find the equation of c. Okay. When you are calculating this, okay, So let's firstly write the coordinate here, right? So the first coordinate that you have here is this, the value of t here. So t is the coordinate of 0 is to 8, and then r, which is that r has got the coordinate of -2 is to 0. You have to note how you wrote your coordinate, because it's always x is to y, x is to y. At this point here, we don't have the value of x. The value of x is 0, while we do have the value of y. But in this case right here, we don't have the value of y. We do have the value of x, because this is the x-intercept. Now we can use these 2 points. So we have y2 minus y1 and over x2 minus x1. Now, in order for you to identify y2 and y1, it doesn't matter actually. So you can pick one coordinate. You can, if you say this one would be your x1 and y1, so this one would be your x2 and y2. But you have to be consistent after you pick your coordinate. Okay. So I would select this ones over here as my y2. Okay, I'll select this one as my x1, y1. Okay. Obviously, this one over here will be my x2, y2, right? And note that I didn't say x1, y2, and I didn't say x2, y1. I didn't say that. It's x1, y1, x2, y2. Okay? Because a lot of people, they don't understand that part. They make a lot of mistake on that part. Okay? So now let's just plug in the numbers. We have y2 minus y1. So your y2 is that, which is 0, okay, because that is y, so that is 0 minus and y, okay, yes, and y1 is 8, so it's minus 8 over. Do you see how I'm writing this, right? It's very simple and neat, right? All the step I'm showing, I started by writing the formula. Then I expand the formula. Then after that, I'm plugging the numbers. All right. And now, my y. Okay, so you go back to your x2 now. So which is -2. So that is -2 minus my y1, which is 0. No, sorry. My x1, which is 0. That is my x1, so it's 0. Okay, which is the correct answer that you got, because that is -8 over -2. Do you see the step, the way I'm writing this, right? I'm not saying the answer that you got is not correct, but I want you to be careful how you write it. Everything must be clear for the marker, right? The marker must see that you are coming from, you are from this step to the step, and that step to that step, okay? So then the final answer will be because negative will cancel that negative, will be 8 divided by 2, which will be 4, which is the same answer that you got, okay? Any question here?
Okay, so it's the same answer.
Okay, so now we got the gradient, so we already calculated the gradient. So once you got the gradient, you're almost done the 50% of the work. So now that means we have the function of g of x equal to 4x plus c. Now our goal is to now find the value of c. As I said, you have to use any of the coordinates that you use to calculate the gradient. So the coordinate that you use to calculate the gradient is -2 is to 0 and 0 is to 8. Okay, so so once you use those two coordinates, you don't need to use both of them. You need to use one of them, and it doesn't matter which one you use because you get the same answer. For the sake of explanation, I will use both of them. Okay, so let's use this one, which is -2 is to 0. If I'm using that, you can see that the coordinate, remember, is written in the form of x is to y. So my x value is -2, while my y value is 0. So I'll go ahead and plug that in here on this equation to find the value of c. So here I will have 0 equal to 4 into, and my x value is -2, so that is -2 plus c. And then 0 equal to 4 times -2, that is -8 plus c. So my c value, if I'm taking that to the side, my c value would be equal to 8. Okay. Now, someone cannot use this coordinate of -2 is to 0. Someone can use this one, 0 to 8. So if we are using 0 to 8, we'll have, obviously we're using the same equation. So we have 0 equal to um, um, sorry, not 0. 8 equal to 4 into 0 plus c. And then 8 equal to 4 times 0, that is 0 plus c. So you can see that c will also be equal to 8 if we are using the same coordinate, right? So it doesn't matter which coordinate you're using, you'll always get the same value, right? But you need to use one of them, right? So now after this we
So
got the value
you
of
have
c.
to. It doesn't really matter which one you pick or which one you do. It matters that it's y and x.
Yes, 100%, 100%. Okay. Then you can now have your function. So your function is f of x equal to 4x, all right, plus 8. So this is your function. Okay. Any question here?
All right, makes sense.
Okay.
It makes sense now. It makes a
Now,
lot. It makes it a lot more sense
yes.
because it's just a simple algebraic equation.
Mm-hmm. Yes.
But
Yes.
I keep on getting mixed up because I keep on writing these things as expressions. You
Yeah.
see,
Yes. Good. Now I'm happy that you understand
I
it.
don't. I write that, but I understand it. I understand it definitely.
Okay. Now let's move on to the next one. So the next question, they are saying use the graph. There's the key, right? Use the graph to determine the values of x for which g of x is equal to f of x is equal to g of x. All right, so once you see the scenario over here, once you see where the two functions are equal, we call that the point of intersection. So where the graph they intersect one another, that's where these two graph equals. So at this point over here and over there, that's where these functions are equal. Okay. So from x equal to -2 and x equal to 0, g of x is equal to f of x, right? So you can go ahead and do that. You say is x equal to um, 0, is x equal to 0 or x equal to -2. So this is where these two functions are equal, x equal to 0 or x equal to -2. Any question here?
No, that makes sense because they both line up and meet in that place, so it makes sense.
Right.
It's simple that.
Okay. So, at these cases, even though they are saying use the graph, right? And then they're saying find x times g of x less or equal to 0, I will recommend that you use the calculations here. Okay. I understand that in most cases this can be quite complicated, but basically they are saying for which where you are multiplying f of x, which is this function, and any values of x, are you getting the value that is less than 0 or equal, that is less than, uh, when you are multiplying g of x, okay, which is the y value, and the x value, and then this function is less than 0. So you have to go to the function, and we can see that this is f of x over here. Okay, for order for me to do this, you want the where this is g of x, right? Where I'm multiplying this function, right, with any values of x. So these are the values of x, okay? And I'm getting the negative function, the negative value. So you can see that basically where you are multiplying, because g of x is equal to the y value, okay? G of x is the y value of the function. Do you understand that? So basically they are asking you where you are multiplying the y axis on the function, and then we are multiplying with the x axis, and then we are getting the negative number, or that is equal to 0. Now, if you are starting from here, so you can see that we have the positive x-axis from this part. From here to there, we have the positive x-axis. All right. Let me just use another color for the explanation. So from here to here, we have the positive x-axis, and then from here to there, we have the negative x-axis. Okay. So this is the zero part. Okay. Now let's do this. Now you can see that at this point over here, right? When I'm starting from here, I have this function over here from this point where the x is 0 up until here. I would have the positive x-axis. This function would be on the side of the positive x-axis, right? So let me just circle this, what I'm talking about. We'll use another color. So from this part of the function, right? This part of the function is on the positive x-axis, while this part of the function is on the negative x-axis. Okay? Do you understand that?
Yes.
Okay. Now, since this is on the positive x-axis, therefore, if I'm multiplying from here, right, from this part, right, if I'm multiplying the x value
I see.
with the y value from this part to this part, I would get the positive number. So I would get I would get x greater than 0. Okay, that's what I don't want. Okay, so now if I'm starting from here,
It's the opposite.
yes, yes,
So it's the opposite. If you were to say, if you were to go on that other side, and you did the same thing, you would get a minus number. Am I
yes,
correct?
yes. But look at this. We are not done. Look at this part. If I'm starting from this point, right, and I'm going down the graph, okay. Now, if I'm starting from this point, and if I'm starting from this point and I'm going down the graph, okay, you can see that I have the negative y-axis while I have the positive x-axis. Okay, now you can see that at this point over here,
Yes.
I'll get the value that is less than 0 because I'll be multiplying the positive x-axis, right? I'll be multiplying the negative y-axis with the positive x-axis, right?
So then from that point onwards, it's a minus point.
Yes. And then if you also come to this point over here, right? At this point, we can see that we have the positive x-axis and the negative x-axis. So starting from 0, going upward, going downward, sorry, right? Oh, no, I'm not correct. Starting from 0 up until here, right? When I'm multiplying because I have the negative x-axis on the side, when I'm multiplying the negative x-axis with the positive y-axis, the negative x-axis with the positive y-axis, I'll get the negative value. But starting from here going downwards, you can see that I have the negative x-axis and the negative y-axis, and then I'll get the positive answer. So I can't include that part.
This makes so much more sense now.
Right?
This makes so much more sense.
Yes. So your x value, your first x value, your x will start from, right? Because I'll start exactly at this point. We'll start from 0 to -2, right? -2. Oh, no. Let me start from negative. No. This is not correct. -2 is to 0. Close the bracket because I'll start from here. Okay, let me use another. I'll start exactly from here to there. Okay, so I have to use the square bracket. Okay, union. right? Union, starting from here, so I was starting exactly from positive 2, all right, to infinity, and then use this. Because why I'm saying to infinity is because you can see that function is continue moving down. I don't know where it would end, so it's to infinity. So your x belong to x, your x belong to negative 2 is to 0, union, square bracket, 2 is to positive, positive infinity, right? Because I have the positive values of x from here to that point, okay? Any question here?
Oh, sure, this makes sense.
Okay, so now I think because of time we can end here for today. But we will continue with this. But the reflection is just a matter of adding the negative, right? But I want to give you a homework now, right?